Okay, so we're going to be talking about data sets in this course. Data sets are really important for us because data are what you're going to be analyzing in a statistics course. The whole idea behind a statistics course at this level, which is an intermediate level statistics course that goes from basic statistics to descriptive statistics all the way up to multiple regression, some diagnostics of multiple regression, and even logit analysis, which we'll do at the very end. So the basic idea behind this is we're going to be analyzing data. So what are data? Data, first of all, are plural. Data is never something you would say data is. Data are. Datum, D-A-T-U-M, is the singular, a single point. But data are, it's a plural word. Data are numbers, numbers used to describe things. So what we're going to be doing is saying we're describing things that we want to understand, and we can understand them better if we have numbers, and with those numbers that describe those things we can then describe not just what those things are in a quantitative manner, but we can also find how relationships exist between two or more different things. For example, if I was interested in the heights in this class, everyone has a height. So if I measured everyone's height and there's 18 people in the class, I would have 18 observations or 18 pieces of information, and each one of you would have a height. So I want to know how to describe that, but then I want to know how to also describe how heights might be related to something else. So this is a political science course, so we're going to be dealing with data that involve politics. So we want to be able to talk about politics, to analyze politics using numbers. Now there's going to be different types of data that we're going to use. We're going to be using qualitative data to some extent, but mostly it's quantitative data. What's the difference between qualitative data and quantitative data? Qualitative data is where you're actually talking about information that describes something in words. And very often people go to sites to get qualitative data when they do interviews and they interview people. The trouble with that type of stuff is it's very hard to get your mind away from just the use of words, and you want to be able to be more systematic. So some people take those qualitative data and code it into numbers. And those numbers then become quantitative data. So quantitative data is what the core of statistics is all about. Whether we have qualitative data to go with it or if we're just with quantitative data. But fundamentally, statistics is used to describe the world. So ultimately, we're going to be ending up with words again. Ultimately, we're going to be trying to describe the qualities of the words, the qualities of the world, the qualities of people, the qualities of political parties, of nations. We're going to be trying to describe that by taking information about people, removing ourselves from the people, using numbers that describe those people, and then going back to words again to describe the people in a way that you like to use just plain sentences. So quantitative analysis is like an intermediate step to understanding people. You start with people you just talked to, you move away, you digest and analyze numbers, and you move back to the people. Thus, that's why it's so important to understand that this is a course in scientific writing. Scientific writing means you're going to be writing about numbers, but ultimately it's writing. So writing is very important in the course. The worst kind of scientific writing is writing that nobody reads. It's very common. Writing that's so complex, so terse, so analytical in the numerical sense. Nobody reads that stuff. Ultimately, you've got to take your statistics and write it in ways that anybody can understand it, even if they don't understand statistics. That's one of the great things about people like Edward O. Wilson. He's a spectacular scientist. He knows quantitative analysis backwards and forwards. But ultimately, when he writes, anybody can understand it. And he writes for the New York Times. He writes for major publishers. People love it when he comes to speak at their universities, and he's spoken here at Emory many times. So it's people that know how to use numbers that can also make that transition back to just talking about things so people understand what they were trying to say, what they were trying to analyze. So writing is very important. So let's talk about what kinds of numbers we're going to be looking at in this course. So for this course, we're going to be looking at quantitative variables, but there's also a certain type of variable that is a little bit closer to the qualitative descriptions that we call categorical variables. Now in your text, I'm looking now in chapter 2, around pages 12, and I want you to be able to follow along with what I talk about with the text, not by opening up your text while we're talking, but make a mental note or make a note of where we're actually getting this information. Remember, this is one of the best texts on statistics for this type of course written in English. So I like to follow the text in terms of organization because it really is a well-written text, except when we get to some areas such as dummy variables, which I will deviate from the text because I do have methods that are better than the ones that are described in the text. But otherwise, the text is really good. So what we're going to be talking now about is various types of variables. Now, there are, among the variables that have categories, there's nominal and ordinal data. Nominal data, nominal comes from the word name in Latin, and so what we're talking about is data that have names, categories that have names, gender, male and female, Republican, Democrat, things like that, liberal, conservative. So they're categories, but they have names associated with them. So nominal data are sometimes very useful for us, especially when we're looking at things like a gender gap for a particular set of parties. For example, with the Democrats and Republicans, there is a gender gap. More men tend to support the Republicans, and more women tend to support the Democrats for reasons that they're still struggling to figure out even today. So when we're looking at some types of information, those nominal levels of information are sometimes very valuable. We also have ordinal levels. Now, the difference between ordinal and nominal data is that male, female, nominal data, female doesn't go in front of male, male doesn't go in front of female. There's no order to them, they just are. Ordinal data actually has an order associated with it. So one comes before the next, comes before the next, comes before the next. So for example, with ordinal level data, we can have a scale. For example, social class, middle is in between, lower and upper. We can also have interval level. We can also have levels such as ideology, which is very liberal, moderate, very conservative, so on like that. So we have orders associated with that. And finally, we have interval levels. Interval levels are very interesting because when you deal with data that are more or less continuous, meaning that you can have any value associated with it. For example, the heights in this class. The heights in this class can be any value whatsoever. So that's clearly a continuous level of measurement that we would have. But sometimes we want to measure it and understand it in terms of intervals. So if you're between here, and then here and here, and then here and here, you have intervals for those things. So you can have intervals in income. People who earn between 20,000 and 30,000. Then people who earn between 30 and 40,000. People who earn between 40 and 50. We have intervals. So intervals are sometimes a useful way for looking at data that are otherwise simply continuous and can have any values whatsoever. So sometimes those intervals are a way to make continuous level data look a little bit more like ordinal level data, things that have actually orders in it or levels. So interval level data is another way of looking at stuff. Now, what we're going to be looking at mostly with the data sets that we use in the class are discrete and continuous level variables. So a lot of these words that I'm using are overlapping. So I'm trying to use the words that we'll be using throughout the course, and we want to introduce just vocabulary to you. So when we're talking about discrete versus continuous level data, discrete values is that the variable has a certain number associated with it, like 1, 2, 3. For example, if we're asking for the ages in this classroom, you're going to have 18, 19, 20, 21, things like that, discrete numbers. Now, if we're talking about continuous level variables can have any value whatsoever. Now, a lot of times we try to create data that we want to analyze that have that flavor of being continuous. So sometimes we create things in our surveys that feel more continuous and act more like a continuous level variable, such as a feeling thermometer, and I'll get to those feeling thermometers in a little while. But the idea is we have data that have discrete values, and those are called discrete level data, and then continuous values as well. Now let's talk about that example that I was mentioning. That looks like a thermometer, right? Now, when you were growing up, your mom and dad probably stuck something into your ear or something like that. But in the old days, they actually had a glass tube with a bowl of mercury at the bottom, and the mom would have to shake it like this to get the mercury to go down. Then they stick it under your tongue, and they wait a few minutes for the mercury to rise to get your temperature when you have a cold or a flu. So that's what they sort of look like, a feeling thermometer. So a feeling thermometer looks like a thermometer, and basically what it is that they have values. Now I'm going to make it very simple for here. I'm going to go 0, 25, 50, 75, 100. Okay? And I'm going to put down here neutral for the middle, and that's cool for 25, and very cool for 0. And then warm for 75, and very warm. Now imagine this feeling thermometer, and somebody would be asking you, because you were chosen to participate in a survey. So for this particular exercise, somebody says, we would like to know your feelings, and we want to know what your feelings are for President Obama. Okay? Well, then they say, well, don't just tell us. We want to know an exact value for how you feel about President Obama. And then they stick a card in front of your face, and the card has a feeling thermometer like that. Now, what they're trying to do is get as close to a continuous level value as they could imagine. So they say, imagine a feeling thermometer. What are your feelings about President Obama? How do you feel about him? And then they'd say, if you feel sort of neutral, it's around here, a 50. But if you feel sort of more warm about President Obama, give it a higher value. And if you feel sort of cool about President Obama, give it a lower value. What are your feelings? Now, theoretically, what they're aiming at is for people in the survey to look at that and say, I feel like a 78.6 or something like that. They're trying to get like an exact value, a continuous value. In reality, most people pile up on the example values that are actually given there. But you get the idea. They're trying to give people the idea of getting any value between 0 and 100. So that's where people sometimes have experiences as participants in a survey where people are trying to get continuous level information out of them. So we construct things like that in order to get that level of continuous data. Okay, now, how would we actually pick that person? Well, picking someone for a survey is a delicate procedure. You have to do it just right. Surveys are based on probability sampling. Not always, but they're supposed to be. The good ones are based on probability sampling. And the best sample that you could get is a simple random sample. A simple random sample, and now I'm referring to page 15 of the book. A simple random sample is where you have a population that you're studying. Now that population could be the world, a nation, a city, a classroom, a university, a college, a state. Do you get the idea? It's a population, and you want to know something about that population. So what you do is you say, I would like a simple random sample of people in that population. Now, why would you ever really want to do that? Why not just ask everybody in the population what you want to know? Well, there's a lot of people. There's over 1 billion people in China. And what if you're trying to study China? There's over 1 billion people in India. And what if you're trying to study India? There's like 300 million people in the United States. What if you're trying to study the United States? Getting a hold of every one of those things is expensive. It all boils down to money. It all boils down to cash. So when you're trying to actually get information about people, you simply can't afford to get information about every person. So what you want is to say, I would like a smaller group of people that I could ask questions, that I could afford to ask questions. And I would like those people to look like the big population. So I'm only going to have 1,000 people I can afford to ask questions to, but I want that 1,000 people to really look as if they came from the whole United States. Does it make sense? I can afford to ask 1,000. I can't afford to ask 300 million. So I want that 1,000 people to look just like the same characteristics and proportions and stuff like that as the whole population in the United States. So that when I ask that 1,000 people what I want to know, I will then know what the rest of the population is in the United States. Well, the only way that will work from a theoretical probabilistic perspective is if you have a simple random sample. That means that you have to have a sample in which it is equally likely for every single person in the United States to have been picked to go right into that sample. You have to have a way of selecting people so that everybody has an equal chance of being selected. That's a perfect, simple, random sample. And then you have some means of collecting that information, and then you're told, talk to these people. If you get them all together, those people will represent in their characteristics what the rest of the population in the United States look like, and you can do that. Well, simple random samples may be good in theory, but in practice they're really difficult. Because, hey, if you're sampling China, China's a big place. If you're sampling India, India is a big place. If you're sampling the US is a big place. Well, okay, so now you have a sample that was, say, picked by a computer, and everybody in the whole country, for example, for the US, had an equal possibility of being picked, and the people and the computer picked it. Well, you have one person in Cincinnati, another person in San Diego, another person way up in South Dakota someplace, some village who knows where, you can't even find it on Google Earth, then another person someplace else, and another person. They're scattered all over. You know what the gas bill is going to be like? Let alone, flying, hiring people to go to all these places. You're talking about cash again. It's like you're out of money. Okay, so I have only 1,000 people I have to ask. It's cheaper than asking all 300 million, but still, can't you do me better than that? I mean, this is like too expensive. 1,000 people scattered all over the country, that's like too much. So again, we're trying to conserve money. So what we actually do in reality is, in academic type surveys, is to come up with compromises to the simple random sample, something that we can afford to do. Now, in the old days, the easy way to do this was simply to use the phone system, because not so many people had unlisted phone numbers, and cell phones didn't exist, and you could just call them up and get them home at night. And you could get pretty close to a simple random sample as long as you had the system the way it was. And then a lot of surveyors started doing that, and then people started getting really ticked off at the surveyors because they were being called regularly, and it became, spam that you got over the telephone. You got phone calls that you didn't want. And then it was also difficult because the random sample that you were saying was saying you were supposed to pick the man of the house, but the woman was answering the phone more often. Or you were supposed to get the kid who's 19 years old, but you had to get through the mom and the dad in order to get in. There's a strange person calling and asking for the 19-year-old girl in the house. I mean, it was hard to actually get through the network to actually find those people that you're supposed to actually get. But nonetheless, it was a fairly good workaround to use phone systems. But now it's even harder because so many people have unlisted phones. Cell phones are unlisted. A lot of people don't even have landlines anymore. And there's also this do not call mentality, which basically everybody does. Like, we don't want to be called by people. We don't want to be called by companies. We don't want to be called by survey companies. We don't want to be called by anybody. So the phone business in doing surveys started out to be a cheap alternative to flying out to getting people to ask questions of people. But then it ended up being sort of unworkable in many respects. It's still used by survey companies, but it's getting more and more imperfect as we go on. So but you can see cost cutting is at the crucial nature. Now we're going to be looking at a data set for this course that is an academic data set where we don't use telephones. We actually had people go out and interview people and actually find them at their homes and talk to them for like 2 hours. That's not a joke. Sometimes 2.5 hours. So if we had a simple random sample, then you're talking about a very expensive operation. So simple random samples that cover, for example, the entire United States are very expensive. There are alternatives that people think of that don't work, such as non-probability sampling, such as who wants to be in our survey, and you volunteer to do it. That's a terrible way to do it. Or you can survey people that subscribe to a certain magazine, such as Reader's Digest or something like that. But that's a terrible way because those people tend to be all alike in certain ways. So what is some of the other ways you can do it if a simple random sample is just not good enough because you simply don't have the money? Well, one way you can do it is called a stratified random sample. And a stratified random sample is where you take a population and you break it up into levels, sort of high class, middle class, low class, income levels, educational levels, whatever. But you sample people within those strata, and you have some means of accessing who those people are within the sample. Sometimes, in some situations, with some populations, stratified sampling is very useful, but it also can be economical sometimes. But more often than not, even that's expensive. So the one that is used the most is called cluster sampling. Now, I don't have enough money to send Jane all the way out to some village in South Dakota to interview the person that the computer picked up. It's just too much money for that one person. It would be so great if I had clusters of people in certain areas, and then I could send Jane out to that area and she could interview 100 people. I just have to fly her to the area once, have her rent a car, and a few days later get a whole bunch of interviews. Do you get the idea? It's cheaper. So cluster sampling is really good. So cluster sampling is often what's done for economic reasons in surveys, so in academic surveys. So how do we do these cluster samples? The clusters have to be carefully chosen so that they represent what the rest of the population is. Meaning there have to be a certain number of clusters that are urban areas, certain number of clusters that are rural areas, like in Iowa, Dakotas, certain number of clusters that are suburban areas, certain number of clusters that are in the south, certain number of clusters that are in the northeast, the west, the Midwest. Do you get the idea? So we have a certain number of clusters. And what we do is we sort of set up a base of operations in those clusters. That means that we keep contacts with people who live in those areas, ideally, so we don't even have to fly them to those areas, but who live in those areas that will work for us in our survey business. Does that make sense? So it's part-time employment, but we've trained them, they're reliable, and every few years we call them up and say it's ready to go again, and they know what to do, and they go out to people in their areas, and those people in those areas are picked by a computer. Now what they do then is they literally hop in their car and they drive out and they find Susie Smith or Joe Schmo in their house, in a farm, wherever it may be, and they knock on the front door and say, we're doing a survey, an academic survey, and they give their bona fides, they give their credentials of who they are, and say, would you mind if I talk to you for a few minutes? Now that few minutes is actually 2.5 hours. Literally, you're sitting down and asking them all types of questions. But you have to train them in order to build trust so that they actually ask all these questions and get answers back, and they carefully record all of the information, and then they send it back to the central base where all the information is being done. So, as you can see, we're trying to get around the cost of a simple random sample. Simple random sample is the best. Cost, got to find some other ways to do it because it's too expensive. Let me give you an example of the hoops that people go through. George Bush. Now that's not your George Bush that you knew when you grew up. I'm talking about the real George Bush, his father. Okay, he was running in 1980 against Ronald Reagan in the Republican primaries. And I was a graduate student, and I tell you, I was doing the most wonderful wizardry you've ever imagined. I was doing three-dimensional plots, I was doing advanced statistics, I was doing this and that. I was like the wonder kid. I got a phone call. The secretary of my department of political science at Washington University, she left a message. The George Bush campaign called. They want to talk to you. I got the message and I said, wow, this is really great. I mean, like, word of my intellectual prowess is spreading far and wide. So I said, I'm going to call them back. And so I literally got to the phone. I made sure I did it in the office of the political science office so that all the secretaries could hear. I was a cocky graduate student. So I picked up the phone and I said, I called up the George Bush office and I said, hello, is this the George Bush campaign office? I'm Courtney Brown, returning your call. Oh, I'm so glad you called. We really needed to talk to you. I heard wonderful things about you. I said, of course. How can I help you? And I was assuming they were going to ask for advice on how to do fancy statistical analysis. I was going to talk to them about stratified sampling, cluster sampling. I know how to cut their budget. I know how to do absolutely everything. I could run their computers, everything. I could give them advice on how to analyze the data. So I said, how can I help you? And he said, well, you see, we're doing a survey. George Bush, of course, is running in the primaries, and we're doing a survey. I said, yes, I know. I figured that's why you called. That's my specialty. So he said, yes. Well, you see, we have a sample. I said, I know all about samples, all the different types of samples. How can I help you? And he said, we have a sample, and you see, somebody was picked in North St. Louis by the computer. And I said, I started at that moment to realize something fishy was going on. So I said, okay. I lived very close to North St. Louis, like 2 streets away. And they described where the person was. And it was in an African-American area that was perfectly fine, but it was an African-American area. And then the guy said, well, you see, the computer picked it, and we have to have a random survey in the clusters, of course, so we've got to get this person. But we don't have anybody that's willing to go there. So would you be willing to drive there and interview this person, and how good is your battery in the car? I swear he said that, meaning he wanted to know if I could escape if I was attacked by thugs and stuff like that. So I said, are you serious? You're afraid to go into a black area in St. Louis, North St. Louis? I live 2 blocks away from that place. What? Are you serious? He said, oh, you know the area. I said, of course I know the area. So he said, well, are you willing to go there? And you do have a car that has a good battery, right? And I just listened to him. I said, this is like crazy. The guy's racist. I mean, the guy was afraid to go to a place that everybody goes to just because there were black people there. And so I listened and I said, this is crazy. You know, I could visit that place and I could interview that place. So I said, but this is just so ridiculous. I'm not going to do it. Goodbye. And I hung up on the guy. So the point is, and before he said, and before I hung up on him, he said, now I can understand. He said, I can understand if you don't want to do this. And I said, well, what do you do? And he said, well, we'll think about it, and if not, we'll just drop that person and ask the computer to come up with somebody else. So, do you get the idea? The computer said, as a random selection from a cluster, pick that person. So he made an attempt. He couldn't find anybody that he knew that was willing to go into a black area of St. Louis. And secondly, he tried me. And I was so insulted by it, I refused to go. And so his option was simply to drop it and to tell the computer to get somebody else, hoping it's in some area that they would be willing to drive to. You get the idea? So theoretically, you're supposed to really go to whatever address is picked and talk to whoever is chosen by the computer. End of story, full stop, that's the end of it. But in reality, people fudge. So that's one of the problems with surveys. You actually have people who are, who's John Bon Jovi? He's the front man for Bon Jovi. Who's Steven Tyler? He's the front man for Aerosmith. Who's Axl Rose? He's the front man for Guns N' Roses. Well, companies have front men also, who present the results to the candidates. And do you think those front men turn around and say, well, we fudged a little with these things. we got you a collection of... No, they actually say, we have a systematic random sample here, or a simple random sample drawn from clusters, and they throw all of the information out, and they buffalo people. So the point is, surveys are supposed to be good, but every time you hear survey results, you always have to ask the question, how was it done really? Now, there are reputations for certain companies. So the companies that we use, actually the universities that we use that do the surveys that we're going to be using in this course, are among the very highest quality. You also get very high quality with Gallup, CBS, those major polls, okay? Those polls that you see in the major newspapers. But when you're talking about candidates running for office, especially when they're trying to use the poll results to show that their candidate is doing well, you really can't always believe everything that you're getting, even if the numbers are accurately presented. There's all types of stuff that goes on the side. So the quality of the survey data is very important. Again, you're trying to get a sample size from a larger population. And that sample is supposed to represent what the real population is like, so that you can have believable information about what the real population is like. Well, if it's done really well, and we have the best people doing it, why don't we just do it for everything? Why do we have... It's like an election is really, really hard. An election is very difficult, and it's very expensive. Why don't we just do a survey and find out what people like, and then have that person be president of the United States? That's because a certain percentage of the time is going to be wrong. Now, how often is it going to be wrong? Well, there is a magic number that is not given by any God-given principle. It's just convention. It's something that was just sort of decided by. Over the years, it was sort of decided that if you can do the surveys so that you're correct 95% of the time, then you're okay. And we will believe the results. That means, and I'm going to get to this later in the course, we're going to have what we call a 95% confidence interval. We're going to have alpha levels of the test and so on. All sorts of new vocabulary we'll introduce. But the basic idea is we want to be 95% sure that the numbers are correct. Do you know how many surveys they do during an election? You'll get 95 surveys in a week. I mean, or more. I mean, they do so many surveys. What if you have 100 surveys and you're all evaluating them at the 95% level? What does it tell you about 5 of those things? If you're 95% certain on all of them, if you do 100 surveys, what does it tell you about 5 of them? What do you think? If you're 95% certain and you do 100 of them, what do you know about 5 of them?
You're uncertain on those 5.
What's that?
You're uncertain about those 5.
No, it's not that you're uncertain. 5 of them, on average, are dead wrong. Not that you're uncertain. 5 of them are dead wrong. And nothing was done incorrectly. So let's say all 100 were done perfectly well with the best of people, with all the money that was needed. 95% of the time you'll be correct, and 5 of them are going to be dead wrong. A friend of mine who worked as an academic, I won't give any names, but he worked as an academic in a university, And he said, you know, I'm going to leave academia. I'm going to go out and make big bucks. So he went up to a major newspaper in New Hampshire during the primary seasons. And he said he accepted a job as a big bucks surveyor. And he knew how to do it right. He was a great survey person. And he went up to New Hampshire and he started, this is during the Reagan and Carter campaign, 1980. And he did surveys, and they were all great. Survey after survey, and things were going so great. And then he finally did his last big survey at the very end. And the publisher was happy, and he was happy, and he came in with the results. Carter wins by a landslide against Reagan. And the publisher looked at it, and this guy had been right all along. Front page, Carter wins by a landslide against Ronald Reagan. Well, what happened in the 1980 election? Of course, Carter lost and Reagan won by a large amount. The next day, the guy was unemployed and wishing he was back in being an academic again. He lost his job. The publisher probably thought he was incompetent. He wasn't incompetent. He did everything right. He did a whole bunch of surveys, and just by chance he was going to be wrong one of these days, and he happened to be wrong on the big one. And he didn't do anything wrong. That's why we don't use surveys for major things like elections. On the other hand, sometimes you have elections that are fraudulent. There are things done wrong. The elections themselves are corrupt. You have this happen not just in developing countries, but in developed countries. And surveys can be used to detect when that happens. For example, sometimes you'll get a result where somebody wins by over 50%. And the surveys come back in, and they were surveying people coming out of the polling booths, actually as they were leaving, and they were surveying people, who did you vote for? And it turns out the person didn't get, anywhere close to 50% of the vote. But the results come back in over 50% of the vote. So sometimes when the surveys are done very well, you cannot be certain, but they sometimes give strong evidence that corruption was involved in the electoral process. And that kind of thing can happen anywhere whatsoever. Now I'll give you my last true story. It's an interesting story about the 1960 election between John Kennedy and Nixon. So this is what happened. True story. It was neck and neck. My parents allowed me to stay up till the wee hours of the night, till I was falling asleep. And we were just watching TV, and everybody was so happy, everything was so going on, and neck, no one could figure out. Finally, I had to be put to bed. Hey, you know what happened? It was really interesting. All the results came in from New York, the Midwest, and California. And finally, Illinois was the only place that wasn't yet in. All of regular Illinois, normal, like rural Illinois, was in. The only place that didn't report was Cook County, which was run by the Richard Daley, Mayor Daley. Now that's not the Mayor Daley that you know, that's the Mayor Daley who was his dad. The last of the big name machine politicians. That was Cook County, run by the Mayor Daley campaign. Run by Mayor Daley. And this is a true story. At about 3 in the morning, there was a phone call between Daley headquarters and Kennedy headquarters. And the phone call went sort of like this. How you doing? Well, it's neck and neck. It's a total tie. It all comes down to Illinois, and all the results are in, except for Cook County, and we have the results, and whoever wins Illinois takes the election. And the guy said, oh, interesting. Okay, well, how many votes you need? Meaning, the rural Illinois was Republican. Cook County was Democratic. So the question was, how many votes do you need? And the guy said back, the rural Illinois has already gotten in, so, we have so many votes we need from Cook County in order to win Illinois. And then the guy just said, oh, interesting, okay. Well, take care. 20 minutes later, the results from Cook County came in, just enough. Illinois went for John Kennedy. Now, I am not saying that Richard Nixon won the election. I am not saying that John Kennedy was not really the winner of that election. I am not saying that. All I'm saying is that there was a phone call between Daley headquarters and John Kennedy. And even John Kennedy may not know. Even John Kennedy may not have known. But the one thing that John Kennedy did know when he entered the office was, I can't mess with Mayor Daley. Because with Mayor Daley, his votes came in last, and he controls the votes coming in out of Cook County. So the issue with with John Kennedy and Mayor Daley is Mayor Daley knew that he needed to have some leverage with President Kennedy afterwards. Now, I'm not saying the election was fraudulent. I have no way to know that. But the phone call did happen. And even if all the results were legitimate, and back in those days, that's always a big question, but even if all the results were legitimate, it still gave Mayor Daley that ability to have that special psychological edge when dealing with Kennedy later on. So you see, sometimes surveys can be extremely useful in finding out where there might have been corruption. So in those days, we could have actually used surveys, but in a nip and tuck election like that, something that was so close, we couldn't have even really found out. So, in something that's that close, unless the surveys came in that it really wasn't even remotely close, we would have had difficulty. But anyway, so surveys are basically used to find out what populations are like. Now what we're going to be going into when we start up again on Thursday is descriptive statistics. And then we're going to get into our first assignment, which will be the use of descriptive statistics, in particular means that we're going to use with the R programming language. We're going to actually calculate means with a data set and start using them. So I would like you to make sure that you've read up through chapter 3 by Thursday. Make sure all of your R stuff is working by Thursday, because you're going to be needing it. You'll at least need R to be working. Whether you have Rstudio working, you should have Rstudio working, but you should at least have R to be working, okay? And hopefully Rstudio as well. R Commander is not a must. We're not going to be using it in the course. Okay, great.
Mm-hmm.